You hear the name Leonardo da Vinci and you immediately think genius, right? But what if that genius wasn't just some magical, unexplainable gift? What if it was actually a formula? In this explainer, we're going to peel back the layers of his masterpieces, look past that familiar beauty, and find the hidden architecture, the science, the chemistry, the math that holds it all together. Okay, let's get into it. We all know this face. I mean, the Mona Lisa is probably the most famous painting on the planet. For centuries, everyone's debated that mysterious smile, calling it the peak of artistic expression. But you know what? The real secret isn't in her expression. It's in the very stuff he used to create her. So that brings us to the big question here. When we're looking at a work by Leonardo, are we just seeing some spontaneous burst of artistic genius? Or are we actually looking at the results of a deliberate, almost repeatable, scientific formula? The evidence? Well, it points way more to the formula than you might think.
All right, to find our first clue, we have to go deeper than the brushstrokes. We need to look at the very foundation of his paintings, that first layer he put down. And this is where Leonardo the artist really becomes Leonardo the chemist.
For 500 years, there's been a secret locked away in the microscopic layers of his most famous paintings. But recently, using some incredible high-resolution tech, scientists found something that, well, it completely changes the game on how we thought he worked. That secret is a compound with a wild name, Plumbonacrite. And here's the kicker. It had never, ever been seen in an Italian Renaissance painting before. Its presence is basically a smoking gun. It's proof that Leonardo was in his studio running unique chemical experiments. So how did he make it? Well, scientists figure he was basically cooking his paint. He'd take oil and mix it with lead-2 oxide, which is an orange pigment, and then heat it up. What he got was this thick, really fast-drying paste. This wasn't just a primer, it was an engineered surface. He turned his art studio into a lab. And you gotta understand, this was not normal at all. The other artists of his day were using gesso, which is like a plaster primer, or painting frescoes on wet plaster walls. Leonardo's method, this custom-cooked lead-infused oil base, was completely radical. It shows you he was always experimenting, always trying to push the science of his materials. Okay, so we've seen the chemistry of his canvas. Now let's move up a layer to how he actually applied the paint. For Leonardo, painting wasn't just about putting color down. It was about sculpting with light and, just as importantly, with shadow. He mastered this with two key techniques, and both are rooted in the science of optics. First, you have Sfumato. That's what gives his work that famous, soft, smoky feel. Then there's chiaroscuro, the dramatic contrast between light and dark that makes things look so three-dimensional. Let's really look at Sfumato here. Zoom in on the corners of Mona Lisa's eyes and mouth. See that? There are no hard lines. Leonardo basically understood that sharp outlines don't really exist in nature. So he recreated that reality with dozens of super thin, see-through layers of paint, blurring the edges until her expression feels like it's alive, like it's actually shifting as you look at it. And listen to this quote from his own notebooks. It shows you just how analytical he was. To him, a shadow wasn't just some dark paint. It was a physical event, a diminishing of light. It was something with rules that you could study and then recreate with absolute precision. So we've got the chemistry of the canvas and the physics of light. Now, let's zoom out even more and look at the hidden mathematical skeleton that gives his art such an incredible feeling of order and harmony. Take The Last Supper. Leonardo's use of linear perspective here is just perfect. Every single line in the architecture, the ceiling panels, the tapestries on the wall, they all race towards one single point. And where is that point? Bam, right on the head of Christ. It makes him the geometric and the spiritual center of the entire scene. It's pure genius. But he didn't stop with just straight lines. Leonardo was good friends with a mathematician, Luca Pacioli, who wrote the book on what he called the divine proportion. We know it today as the golden ratio. It's this special number that pops up all over in nature, and it's thought to create the most beautiful, balanced-looking shapes. And this wasn't just a theory for him. He put it right into his work. If you break down The Last Supper, you find its whole structure is built on a framework of these golden rectangles and stable triangles. You might not notice it consciously, but it gives the painting this deep, subconscious feeling of balance and divine order. Okay, now here's a number you've probably never seen before. 111.24 degrees. That's not random. This is another secret weapon in his geometry toolbox, and it's all about creating dynamic movement. That number is the golden angle, and it's derived right from the golden ratio. Researchers have found these angles all over his paintings, defining the composition. Think of it like this. A golden rectangle creates harmony in 2 dimensions, right? Well, the golden angle helps build that harmony in 3 dimensions. It creates depth, movement, and it guides your eye through the painting in a way that feels totally natural. We've covered the canvas, the light, and the geometry. But Leonardo's last, and maybe his most mind-blowing scientific trick, was his attempt to paint something that's totally invisible. He figured out how to paint the air itself. He was the first person to really study and write down the rules for what we now call atmospheric perspective. He just noticed that the atmosphere sitting between you and a distant mountain changes how you see it. It's not just smaller, the color and the clarity actually change. And check this out. Once again, you see the scientist giving the artist a clear, testable rule. This wasn't just a feeling for him. It was a principle of physics. He was treating the air like a physical substance that had predictable effects on light. He broke it all down into 3 basic rules. First, a blue shift. Distant things look bluer because of how light scatters. Second, desaturation. Colors get washed out. And third, a loss of detail. Everything gets fuzzier. He understood the physics of it. And now let's see this formula in action. Look at the background in his portrait of Leonardo da Vinci. It is a perfect textbook example. The landscape that's bluer and hazier and less detailed the further back it goes. The result is this incredible illusion of deep, vast space behind her. He's literally painting the air. So, when you put it all together, the experimental chemistry, the physics of light, the hardcore math, the science of the atmosphere, you start to see what's really going on. It's a completely integrated vision. This is the formula. It's not just one thing. It's chemistry, optics, math, and meteorology, all synthesized and working together for one single artistic goal. For Leonardo, there was no line between art and science. He just used the tools of one to perfect the other. And that just leaves us with one final mind-bending question. After seeing how deeply all this science is coded into his art, is he an artist who used science? Or was he actually a scientist, and paint was just the best way for him to publish his findings about how the world really works? When you look at the evidence, it seems like for him, there was never any difference at all.